Now let's look a little bit more into the extract, transform, load process. And this is typically the way that data moves from the data sources into a data warehouse. So it's important to understand how this works. First, uh, let's consider ETL as an architectural standpoint. So it's a pattern that represents pulling data, changing that data, and then loading that data into a new location that contains a different design than the original data sources. So the extract portion of this retrieves information from an existing data store, whether it's a relational database, a column-oriented database, a document database, NoSQL, or just a simple text file, or an Excel file, or a CSV file. The transform process then takes that and changes that extracted data into a format that would match the location to which we want to load that data. So the third step in the process is loading that data and placing the transform data into the new data storage system. So when do you use it? Well, first thing is when you need to move data across systems or within systems. So this is often necessary when you're connecting two separate systems that have data storage needs. And sometimes it's necessary when you do not want a system to directly access a production database. So in the case of a data warehouse, you're taking the production database data and you're moving it into a data warehouse format that's easier to use and less taxing on the production database itself. A second time to use it is when you want to load data into a read-only database like a data warehouse or a data mart or an operational data store. So an operational data store, by the way, is typically a smaller scale data warehouse that is used simply for reporting, and sometimes it even mirrors exactly the production database system that you have. And a third reason is when you want to do data mining. So often you will extract and transform data into a format that you want to load into something to do data mining or decision support work. ETL processes should be these things. They should be reusable. This is something that you want to do repeatedly so that you do not have to worry about some of the things that typically a database administrator might do, like writing scripts to get these things into the system and so forth. You want it to be schedulable, so it's something that runs on a regular basis. You want it to be scalable because often data warehouses, as we said, get up into the petabyte and exabyte scale, so it's very large volumes of data that you have to deal with. You want it to be efficient, but not necessarily fast because there are limiting factors based on the speed. So doing things as efficiently as possible may not be the same thing as being fast in this case. You also want it to be maintainable so that it's easy to understand and it's easy to change when you need to change it. The data formats that you're using and the design of the data can change, so you want to be able to change that in a way that's not as detrimental to the process that you already have in place um, as it could be. So here's the overall architecture where you have sources, you have a staging area that collects the data, and then the extract process places the data from the data sources into the staging area. The transform then manipulates the data in that staging area, and then the load process moves it from the staging area into the target systems. So the sources are data stores that you extract the data from, and it's usually not a single table, and it's usually not a single database. And it's often a collection of tables in a large production database or a collection of tables in multiple production databases. So the processes may collect information from those multiple sources that have different architectures. Like I mentioned, NoSQL databases, CSV files or flat files, XML documents, or you could even do screen scraping or web spidering to collect things from an online source. The extract process pulls that data from those sources and makes the data accessible into a staging area for further processing. And it may require that you add structure to unstructured data so that you can manipulate it a bit. So overall, the objective of the extract process is to retrieve all the data that you need from all the sources that you have with an impact that does not really affect those resources as much as it could. So minimal performance impact on the sources, minimal performance or time impact on those sources, and minimal or no locking in those sources. All of those things could happen, but we want to try to minimize that as much as we possibly can. So to do extraction, there are several methods. You could do an update notification where the source system notifies the extract process that data has been modified. It's the easiest way to get data, but you have to rely on the source system to keep track of that. And if you don't trust that, then there might be a better way or a different method that would work better for you. But it is the easiest way to get data. Another way to get data is through an incremental extraction, where the source system identifies the records that have changed over time and provides you with an extract of only those records that have changed. Or you could do a full extraction where the source system is fully extracted and saved so that you can identify changes and move things around accordingly. The problem is that extractions can become very large, especially in those systems that are to the petabyte scale. So we want to ensure that this moves efficiently, so a full extraction might not be the best way. In the data staging area, that's the holding place that contains the data you've extracted. The next thing it does, serves as, is a holding place for the intermediate steps like data cleaning. So as you're moving things into the staging area, you're probably also doing some data cleaning to ensure that that data is ready to be transformed. And it often has the same layout as the source, especially in incremental and full extractions. And then you convert it to the transformation and the load format through the staging process. But it allows you the ability to restart ETL if necessary. And the extracted data may be malformed in the cleaning, and that's where you would do it. So data cleansing is a process that after you extract things, you may need to validate that the extraction contains good data. And if it doesn't, then you may need to clean that data through certain processes. So data cleansing applies basic unification rules to make identifiers unique, convert null values to standard not available values or something like that, converting phone numbers and zip codes to standardized formats, validating address fields, converting those address fields to proper naming, and so forth. That's the cleansing process. It is different from the transformation process. This is to unify the data so that it looks the same across the staging platform. And that makes the transformation process easier to do once you have a clean set of data. So the objective of the transform process is to apply a set of rules to transform the source format to the target format. And it's much more extensive than simple data cleaning because you have a lot of different transformations that you can make on the staging area, the data in the staging area. Selecting only certain columns to load, that might be something that you would do in a transformation. Or selecting null columns not to load. So if the source data has 3 columns and the selection may only take 2 columns, or the selection mechanism may ignore all records where the column is null. Translated values. So the source system may code male as 1, female as 2, but the data warehouse codes M and F. Encoding freeform values, so mapping M and male together. Other transformations may include deriving a new calculated value, so sometimes you want to actually store a calculated value in a data warehouse, so that might be something that you would do to do the transform. Sorting and ordering the data based on the columns to improve search performance. Joining data from multiple sources so that you do not have to do the joins in this database that you're extracting into or loading into. Aggregating data, like doing roll-ups to summarize multiple rows, like the total sales for each store, for each region, and so forth. And remember, the data warehouses should allow you to drill down into the data as much as possible. Gathering surrogate key values, so keys that are not really real, but are used to ensure that you have a unique identifier in the destination tables. Transposing or pivoting, turning multiple columns into multiple rows, or so forth. Other transformations include splitting a column into multiple columns. Maybe there is a comma-separated list in a field, and you don't really want that in a data warehouse, so you would split that into multiple columns. You might also disaggregate repeating columns, looking up and validating relevant data from lookup tables to ensure that you have the correct format for a particular set of data, and applying any type of data validation. Failed data validation may result in rejection of the data, a partial rejection, or no rejection at all. You accept what it is. But none, some, or all of the data is handed over to the next step depending on the validation rules that you have in place. Many of the transformations may result in exceptions, so you have to come up with methods for handling those exceptions in your transformation process. Finally, the last step is to load that data, and the objective here is to place the extracted and transformed data into the target system or systems. This can be the largest bottleneck to the process because it takes a lot of time to move data from one system to another, especially across a network. And that's why you might want to use an incremental style rather than a full extraction, because it takes a lot of time, and that just adds additional time to it when you're moving data like that. Methods of loading: using physical insert statements, linking extraction, transformation, and load all the way from the source to the target. So there are some tools out there that allow you to define and run the extract, transform, load process from end to end. And those tools are very helpful in doing that. But a lot of times, especially in an analytics situation, you may not have the luxury of using those, or it might be a little bit of overkill to define those. So it's often better if you define your own set of extract, transform, and load scripts so that you can move things from source databases into things like data warehouses that will be used for decision support or for data mining or other analytics type processes.